Okay, today we're going to learn about quadratics. And so the first thing you're going to do, you're at my website, and you're going to play the video. It says the video below represents the shot that Dante misses. Dante knows that there is a mathematical function that will allow him to make the shot each time. Your job is to prove that he is correct. So what I want you to do now, I just want you to play the video a couple of times to see what happens when Dante tries to make the shot. Do that with your Chromebook. That's on the 12 shot. Okay, so this is what Dante does. You saw it a couple of times. We're going to show you up here. Okay. All right. So on your paper that you have, it says at the top, it says the picture below represents the shot that Dante misses. Below is the table of the mathematical representation of the equation of this type of function. Use the table to find the equation of this type of function. So let me say this first. What this table represents is the type of function that Dante and the basket Dante's shot is making. It's the type. It is not the actual function. Okay? It's the type of function that this shot is making. So, it says again, the picture below represents the shot that Dante misses. This is the shot. Below is the table is right here, of the mathematical representation of the equation of this type of function. It is not the exact equation for this. Use the table to find the equation of this type of function. So, CP, Amana, means you have reached a teacher checkpoint. You may not move on until I have checked your answers. So when you go through the paper, Lucy, you will see, hey, I got to do this, and I read this directions, it tells me to do this, and I do this, and I notice CP. CP is checkpoint, specifically my teacher checkpoint. So you cannot move, Jordan, to this. Now graph your equation using gizmos. You can't do that until I have done what, Jordan? Checked it. That's what CP means, checkpoint. So you're going to go through and do that using gizmos. And so I'm going to show you what gizmos does. So let's scroll down to gizmos on the same screen. Log in. All right, so we have this gizmos. Raise your hand if you do not see what's on my screen. Good. Everybody has the same one. All right, so this gizmos is called quadratics in polynomial form. I'm going to tell you, well, let me say this before I tell you. Where have we seen this section of this equation? Y equals this. Where have we seen this so far? Just this section of ax squared plus bx plus c. Where have we seen that? You raise your hand. Where have we seen ax squared plus bx plus c? Where have we seen this? Okay, Trinity.
Standard form.
Standard form of what?
Who's factor?
I'll take that because I haven't called the standard form of anything. But we were just factoring. Test yesterday?
Oh yeah.
Okay, we were just factoring. And this has a special name, 1, 2, 3. What?
Yeah.
Factors of C, the add to give you B. When A is not equal to 1, slide and divide. Yeah. Maybe y'all's test is really not a reflection of what you really know. Maybe it's just a one, or maybe y'all one-hit wonders. I don't know. We've had this for like the whole 3 weeks. That's all we've been doing is factoring and multiplying and foiling to get a trinomial. And All right, move on. Okay, so we have ax squared plus bx plus c. So this is, I'm not going to say that because y'all will discuss that later. But this is the equation of what is making this function right here. So in gizmos, you have, don't do that. You do not touch your computer. Watch me. Thank you. All right, so in gizmos, your A can be manipulated. This is your A. A is represented by this, because you see A right here. It can be manipulated by dragging this over, like this, changing the numbers, changing the numbers, changing the numbers. So your numbers go from negative 8 to positive 8. That's all we'll have. You want to be greater than that, too bad gizmos doesn't do that. Okay, your B can be changed. Your B, which is located right here, can be changed by dragging this over, dragging this over, dragging this over. It goes from negative 8 to positive 8. And then your C can be changed by dragging this over and dragging this over. So it goes from negative 8 to positive 8. So if you don't want to drag, you can click and put in your answers, but they only go up by tens. Okay? Any questions on what I said about A, B, and C? I don't want you to understand what it does. I just want you to understand that you can manipulate your graph by dragging it over to the left and to the right, changing the numbers. Any questions about what I said so far? All right. So what you're going to do is, the last thing I need to show you, because I almost forgot to say this. You also have a table. Yay. So, based on your equation, you have the same table that is making this function right here in the graph. So the controls, control your A, B, and C, and then you have your table here. You click here, you can see the table of values that are from this particular function. Got that? We'll keep that. All right, so on the paper, it says, again, I'll go over this and then you're going to get to work. It says, the picture below represents the shot that Dante misses. The shot that Dante misses. Below is the table of the mathematical representation of this type of function. This is the table that represents a function that makes something that looks like this. It is not the exact function from the picture. CP means you have reached a checkpoint, a teacher checkpoint. You do not move on until I have checked your answers. And so the way that I'm going to remember that I have checked your answers is I'm going to come around and stamp. When you get done with a particular section, you'll raise your hand and say, Mr. O'Neill, can you check this? And if you are right, I will check your paper with the stamp. It's a smiley face. And so you can move on to the next section. If not, I will tell you to go back and revisit, or I'll give you a leading question. All right? So you are able to work with 3 to 4 people, no more than 4 people on this. And so you can decide who you're going to work with now. 10. 8. 7. 5. 3. 2. 1. All right, everybody should be in their group. So what you're doing now, you're going to answer. You're going to answer the questions. Where's your Chromebook, Jordan? Can somebody pass it over? No, I'll take care of Jordan. Now you're going to answer the questions. I'll be coming around to the groups.
So it's the opposite square root. Yeah. Then it would be a positive. So it's kind of positive.
Yeah, how does it say negative?
But these are all Did you guys
Negative.
Okay, so now you must use gizmos to graph.
Oh, you do. I feel like this
The blasphemy.
That's it.
You gonna
So the negative would just go to fraction. I'm not the fraction. So we can't have I in the equation. That's
I'm right here. Mathematically not what can give
So let's just write it above the so we'll be
Well, y'all computers Okay, let's follow the directions. It says fill in the missing parts of the table. Have y'all filled in the missing parts of the table?
Yes, we tried.
Okay, should you try to or did you do it?
We don't know if they're correct.
Okay, well look at a pattern. Can you see a pattern in the table, y'all?
Yes, 5, 4, 3, 2, 1. 5, 4, 3, 21. This don't. Yeah, then this one just don't. This one counts. No, it's not squared because if a negative squared by like negative, yeah, positive.
But you know that there's
Even if it was times by something would be
Yeah, it would be positive.
actually numbers. Okay, it don't even matter. It's times itself.
Okay, times itself. All right, but times itself. Right? Negative 5.
That's two different words.
Yeah. How? No, because if you have negative 5 times itself is negative 20.
But look, 2 times 2 doesn't do
Oh, the reciprocal. The reciprocal. No, reciprocal.
What is the reciprocal?
The opposite.
What is your reciprocal?
Reciprocal is not opposite. Reciprocal is flip.
Yeah.
Wait, so think about it. Look, negative 2 times 2 is negative 5. No, the opposite of negative 5 is 5. And we'll be 1/5.
So how about y'all start with what you know? What do you know?
I know it's going in. It's not
Okay, let's get constant will imply what about your graph?
has
Okay, constant would imply what about this graph? What's constant mean in math terms?
it's always it's going to go
Y'all,
down.
let somebody else talk.
It has a vertical.
Somebody else. What does constant? A constant rate of change produces what type of graph? Linear. Is this constant? Why is this not constant?
Oh, because it's not straight.
So I'm telling you all to go by Okay, what else? What pattern do you see that's happening from your input to your output? Okay, let's start there. Let's go for that. Okay, no. I don't know, does it? Does that work? Yes. Okay, y'all asking me, y'all should be telling me this works. This Okay, the next thing it says, now graph the equation using gizmos. You have to graph this equation using gizmos. I'll be there right after I come in. Get y'all another sheet of paper and the second one. Yeah, once you simplify Every time?
25.
I don't know that. And not everybody
Yep, that's the next page. Yes. So what you had worked, but I want you to see it this way. Yeah, the next thing says now graph your equation using gizmos. You're going to use gizmos.
And then the rest of the
We have to Google the.
Simplify this. Simplify this. Somebody will do it.
what?
Look at us.
Y'all done? Not y'all. I need y'all to come up with a consistency for y'all follow this.
This is our So it will be -1 times x squared. Okay, so.
Okay, just a little bit. Cesaria said,
Because math.
trying not to give y'all so much, but Cesaria said that if you square -5, you get what? You get what? 25. When you square -4, what do you get? When you square -3, what do you get? When you square -1, what do you get? So what's the issue that we're having? Stop. I want to hear from one of these three. Thank you. And so can y'all come up with a mathematical way to make what we are getting negative? I'm just trying to distribute it. Okay, the next thing is that you need to graph your equation using gizmos. So you're going to graph this equation using gizmos. Here, what's next? Who wants to have this group? Anybody after this group? And y'all. Alright. Yeah, I need you to prove that this is 4. Yeah, turn around, pay attention to this. Okay, so
Wait, are you doing the graph?
your reasoning could be correct. It is logical. But when you make the shot, I'm talking about when the ball goes through the hoop, not after it goes through. Why?
Because that's when it
It makes sense. It doesn't make sense. You want to answer that right? Okay, so change it over. So I can understand. Yo, who's gonna be after y'all?
Is it a squared plus 2ab plus c?
Equation does not.
Mr. O'Neill.
What y'all
Do you want me to
try?
record?
Yes, keep it. It doesn't work. Y'all are very close. Your method of solving this is very close. But this would be 4.1 times x. So what was your x? What x value is x 3? So this. Where's your math at? Okay, so I want you to prove, use another point. So
the highest is 10, right?
x is, of course, that. So x is
Wouldn't the highest be 10?
4. Y'all get this. Y'all are very close, but that's not the right answer. And put this in your table. Check your table and see if that is right. What do you mean? Y'all. Anna, see, it'd be nice if you join me. All right, so we're going to go over the first two sheets so that there is a clear understanding of the math that I want you to get to. All right, buddy, work with me today. Okay, so we have a picture of Dante shooting the basketball, and we talked about this section here. And you were asked to fill in the table, and you all filled in the values, and you got the function of what, Alex? What was the function for this particular part? Is the x squared in parentheses or outside? Okay. All right. And then someone, I don't know if it was this class, it's two of y'all doing this classes. Anybody in here had a different equation that I asked you to change or to simplify in the beginning? I know somebody in this class had a different equation. What do y'all have?
The absolute value.
Okay, yay, you didn't have the absolute value. So y'all had y is equal to what?
Like a negative.
Uh-huh.
And then the absolute value lines with x squared in the middle.
X squared in the middle. Okay, and this worked. This worked. Why would this work? Anybody can tell, not this group, why would this work for our table? Anna C.
Because the absolute value changes the number, even if it's a negative, to a positive, and the negative outside of the two lines makes it a negative, so it's always going to be a negative number.
Okay, then a little further, why this and this works. Why do they both work in this table right here? Isaac.
Because the negative squared is a positive, and the positive squared is a negative. So
The positive squared is a what?
the positive squared is a positive.
Okay.
So even if it is absolute value, it still be positive.
Okay, so